The SV3 D-PHY generator is a flexible tool that's capable of generating any kind of traffic over a D-PHY physical layer. In previous sessions, we showed how the SV3 can be configured to create color bar patterns, for example. And in today's session, we focus on the ability to create algorithmic test patterns that may not necessarily represent real images. And so to set up this demo, I start with the IntrospectESP software in its default state. So I have the D-PHY generator component as before. It's configured to create a color bar pattern, and the color bar pattern itself is the CTS, the Conformance Test Suite HS test pattern. So this is the default configuration of the software. I had previously run it ahead of this session, and the scope view is shown here, where I attached lane 1 of the D-PHY generator to channels 1 and 2 of the oscilloscope, and the clock lane of the D-PHY generator to channels 3 and 4. So we're seeing the positive and negative terminals of the data lane and the positive and negative terminals of the clock lane. And what we're seeing here is basically the one packet of the CTS color bar pattern that's just playing continuously. And so we'll go ahead in this demo now and modify this to create an algorithmic pattern, and I'll do this live here with you. So the first step in creating the algorithmic pattern is basically to ask the IntrospectESP software to disable the pre-built color bar. So I'll click on false here. And what this does is it gives me a set of extra parameters that allow me to really configure my new algorithmic pattern or my new color bar pattern in terms of its grid and in terms of its values. So in today's session, I'm interested to create a checkerboard pattern. So I want to create a grid of different values and different bytes basically across the physical layer. So I'll enter a grid of 8 by 8 or 64 bytes, and I will ask the tool to allow me to enter raw bytes. So I don't want to be encumbered by any kind of format of the image. I just want to enter raw bytes. So I click raw. And now I should just simply enter the values that I want to transmit. So I'll go ahead and just enter some values here to fill the grid, and it will take me a second. But I'll start with 0 to 55. So I'm entering the minimum value of the byte, which is 0, and the maximum value of the byte. And in color space, this could correspond to a black versus white value. But really here, I'm just sending bytes. So 0 to 55. So I just entered 8 different bytes, which really fills one row of this grid that I want to create. And I'll just go ahead and just enter the second row. And because I want a checkerboard pattern, I'm going to reverse the bytes. So I'm not going to enter 0 to 255, but I'm just going to say 255, 0 for the first 2 bytes. So this is a total of 2 rows that I just created that are alternating in values, and I simply have to multiply this, copy this, and paste it 4 times basically to complete my 8 columns. So I pasted it 4 times, and now this array that I just entered basically has 64 values, and they're just alternating values. So these modifications, I basically created an algorithmic pattern. It's a very simple algorithm that I implemented right in my head. And I entered it inside the GUI. Of course, as is the case with everything else in IntrospectESP software, the algorithm could be written within the Python test procedure and passed to the component class algorithmically through the code. For today, I just used a very simple algorithm that I could just enter manually as I did here. So I'm ready to execute the test now, and when I click run, a couple of things happen when I click run. One is the tool gives me a preview of the pattern that it generated, and as you can see, if I hover my mouse over it here, I already see the preview. I could open it and basically see that we've created alternating 0, black and white positions in the image. There is 8 of them across the horizontal axis here, and 8 of them across the vertical axis, exactly the way I asked. And so the tool gave me a preview of what I created just to make sure that it was fine, but certainly also we have been connected to the oscilloscope, as I mentioned, and we're seeing now how the pattern looks like on the scope. And if you recall, the bytes that I entered were very simple. They're 0 or 255, which really means all zeros or all ones. And so if we look at the positive terminal of the lane here, it's alternating between all zeros and all ones. Just zoom out just a little to see a view of the packet. So that's the entire packet representing the checkerboard pattern. I will zoom in just a little at the beginning of the packet here, just to see that basically what we see here is the start of transmission byte plus the header information for the packet. And so that's just information that sets up the packet properly. But really beyond that, once we're done with that, what we're sending is just all zeros versus all ones. So in this quick demo, I just gave a very quick overview of how to take the standard tools within the IntrospectESP software and modify them to be able to create algorithmic test patterns.